Hello, my dear students. Let's look at the next question. The rate constant for the first order decomposition of H2O2 is given by the following equation. Log of K is equal to 14.34 minus 1.25 into 10 to the power 14 K by T. Calculate EA for this reaction and at what temperature will its half-life period be 256 minutes. So what data do we have? We have log of K is equal to 14.34 minus 1.25 multiplied by 10 to the power 4 divided by T. By comparing this equation with, we need to calculate EA and we need to calculate T when temperature when T 1 half is equal to 256 minutes. So first we have log of K is equal to log of A minus EA upon 2.303 RT. From this, comparing these two equation, we simply understand that this is the value for log A, and so for log A we can easily write 14.34. Now we have EA divided by 2.303 RT is equal to 1.25 into 10 to the power 4 divided by T. So this T and T get cancelled and ultimately we get EA upon 2.303 R is equal to 1.25 into 10 to the power 4. Now, therefore, EA is equal to 1.25 into 10 to the power 4 multiplied by R multiplied by 2.303. By doing all this multiplication here, we can easily find out that your EA is equal to 239. Here you can see the value 239.34 into 10 to the power 3 joules. This 10 to the power 3 means kilo. So that is why we can easily write EA is equal to EA is equal to 239.34 kilojoule. Now here we have T1 half is equal to 0.256 minute. T1 half is equal to 256 minutes. But we know that T1 half is equal to 0.693 upon K, and therefore K is equal to 0.693 upon T1 half. We put the value of T1 half as 256, and finally we get K is equal to 2.707 into 10 to the power minus 3. So here we have got the value of K. Now we are given the equation as log of K is equal to 14.34 minus 125 into 10 to the power 4 divided by T. So for K we can write 2.707 into 10 to the power minus 3. For log of 2.707 we can write 0.4325, and for log of 10 to the power minus 3 we can write minus 3. So finally we get minus 2.575676 for this value, and this minus 2.5676, and rest of the equation is same, there is no change into it. That is your 14.34 plus he your 14.34 minus 1.25 into 10 to the power 4. So this is your 1.25 into 10 to the power 4 divided by T. Now what do? We take this term left side and we move this term right side. So what finally we get is 1.25 into 10 to the power 4 divided by T is equal to 14.34. This minus turns positive plus 2.5676. Ultimately we get 1.25 into 10 to the power 4 divided by T is equal to 16.9076, and therefore you can write T is equal to 1.25 into 10 to the power 4 divided by 16.9, and therefore by doing this calculation you can find out that your T is equal to 740 Kelvin. So this is how you can get the value for T, my dear students. Now we'll move to the next question. That is your question number 10. The decomposition of A into product has value of K as 4.5 into 10 to the power 3 second inverse at 10 degrees centigrade, and energy of activation 60 kilojoule per mole. At what temperature would K be 1.5 into 10 to the power 4 second inverse? So here the data we have is K1 is equal to 4.5 into 10 to the power 3 second inverse. T1 is equal to 10 degrees centigrade, that is 283 Kelvin. Your EA is 60 kilojoule, that is 6000 joule per mole. Your K2 is 1.5 into 10 to the power 4 second inverse. We need to calculate T2. So to calculate T2, we will use the formula log of K2 by K1 is equal to EA upon 2.303 R into 1 by T1 minus 1 by T2. Here, my dear students, the value of 2.303 multiplied by R is 2.303, 8.314, that is your 1. 19.147. That is how you can get. You put the value of k2 as 1.5 into 10 to the power 4. You put the value of k1 as 4.5 into 10 to the power 3, and that is how you can find out log of 1.5 into 10 to the power 4 divided by 4.5 into 10 to the power 3 is equal to log of 1.5 divided by 4.5 into 10 to the power 4 minus 3. No, this is how you calculate this. So log of 1.5, you just write 1.5 divided by 4.5, and 10 to the power 4 minus 3, you take this power upside and it turns as 4 minus 3. 1.5 divided by 4.5 is 1 by 3 into 10 to the power 1, that is 10 by 3. 10 by 3 is 3.333, and that is how you get 0.5227 is the value for this log. Now you take this value as 0.5227 is equal to 60,000 divided by 19.147. That is what the value of 2.303 into 8.314 into 1 divided by uh, 283 minus 1 divided by T2. So now you move all these terms on the this side, so you get 0.5227 multiplied by 19.147 divided by 60,000. You divide this with 6, you get 0.0871, and this is 10 to the power 4, that is equal to 1 upon 283 minus 1 by T2. So you can easily write here that is equal to 0.087 into 19.147 into 10 to the power 4 minus 4. This 10 to the power minus 4 comes from here, is equal to 1 divided by 283 minus 1 upon T2. That is, when you do this calculation here as I have shown here, you get 1.6 into 10 to the power minus 4 is equal to 1 divided by 283 minus 1 upon T2. So this is your 0.00016 is equal to 1000 into 10 to the power minus 3 divided by 283 minus 1 by 2. This, if you do the division, you get 3.53 into 10 to the power minus 3 minus 1 by T2, and by putting this value 0.00016 is equal to 0.00353 minus 1 by 2. You can see here the calculation that if you take this 1 by 2 this side, this minus turns into positive. So 1 upon T2 is equal to 0.00353 minus 0.0016. By doing this subtraction, you get 1 by T2 is equal to 0.00337, and therefore T2 is equal to 1 divided by 0.00337. That is your 1 lakh divided by 337. Ultimately you get T2 is equal to 296.7 Kelvin, and if you turn into degree centigrade, it is approximately 24 degrees centigrade. My dear students, I hope you are enjoying. Happy learning.